Welcome. So let's jump into a new topic. We're going to move away from real numbers and all that stuff with rational numbers and so forth. And we're actually going to move on to induction. So, as a reminder from discrete math, the principle of mathematical induction is suppose I have a sequence of statements, P1, P2, Pn, that for each number. And we assume that the first one is true. And then if it's true for some k value, then it has to be true for the next value, k plus 1. The reason for that this is again works is if one is true, if statement one is true, then we get this first one. And this essentially tells me that if one is true, then two has to be true. But now two has to be true, so three has to be true. Well, now three is true, so four, and it just continues on. It's like it's an infinite loop. So the way we often prove this, as a reminder, is we have a base case and we have mathematical induction. Base case, hypothesis, mathematical induction. So since you've all done mathematical induction before, I'm going to let you loose on a couple of these. That actually should look familiar. This one is missing a key part. It's missing an I. So that really should say, let me rewrite it over here down below. The sum from I equals 1 to n of I is equal to n times n plus 1 over 2. Now, there's a way to prove this without mathematical induction. I can do what's called combinatorial proof, but I want you to do this with induction. So you're going to need a base case. So in this one, I will help you out. The base case would be n equals 1. And then I'm just trying to see if the sum of I equals 1 to 1 of I. The question is, does that equal 1 times 1 plus 1 over 2? So are these equal? That's your first base case. We're going to suppose it's true. Our induction hypothesis is going to be supposed true for n equals k. And then we're going to do the induction step, which is going to be consider n equals k plus 1. And so in other words, you're going to look at the summation of I equals 1 to k plus 1 of I. And the question is, does this equal, after a whole bunch of gibberish, k plus 1 times k plus 2 over 2? And you have to figure out what that gibberish is in the middle that lets me bridge this gap. So this is the first induction problem that I want you to work on. The second one is that 3 divides 4 to the nth minus 1. Again, you're going to need a base case. You can start with all the natural numbers. So you can start with n is 0. What's your induction hypothesis, and how can you prove the next step? And then 6 divides n cubed minus n. Sorry about that. So this one is actually going to be very similar to this one, except the fact that there is all n's going on here. And so this is going to be a little bit more complicated, but I promise you can do it. All right. This is an interesting one. I want to have you give it a shot. So this is an interesting one. So let's say P1 through Pn are distinct points arranged on a circle. All right, so let me draw that. Draw a pretty little circle. So here's a point, P1, P2, P3. We keep going around until we get Pn. All right, I don't have to have it all the way so Pn's over by P1. We don't even know. Then the number of line segments joining all pairs of points is n squared plus n over 2. So in other words, the number of line segments that go from here. So in this case, if I just did this, I have 2 line segments, 3 line segments. Truthfully, in a circle, these are going to have lines, and then there's also going to be a line here. So I just drew in 6 lines for 4 things. 4 squared, So 1, 2, 3, 4, 5, 6. I'm just counting my stuff. So I'm trying to show the number of all these pairs of points, all the line segments. So if I did this for 4 points, n would be 4. So are we missing something? How do we deal with this, etc.? All right. Good luck. Let me know what questions. I think this actually that's an error. That's typo. That should be minus up here. Yeah, this should be n squared minus n. Sorry, just realized that was total typo. All right, so that's your questions I want you to work on. Again, so I want you to do this circle one because it's a different kind of problem, but still work on it. This 6 divides n cubed minus n. This 3 divides n to the 4th minus 1. And this one, which is again missing the I, that's actually your function variable. All right, good luck. Let me know what questions you got.